So, well, might as well leave that down. Tangent. One thing that you're going to learn today that will prove very helpful is that tangent can be written as sine over cosine. I was kind of waiting to see if any of you noticed that from all those problems that we did, that tangent always ended up just being sine over cosine. Everything else just canceled off. The hypotenuse canceled off every time if you took sine over cosine. Okay. And the nice thing is, and the reason that you need to know that is on the unit circle, we have sine and cosine. And so we can actually go ahead and find those values if we have to, or we could just look at the triangle if you want. It's going to work out either way. I'll show you that. But based on what we did yesterday, I said if there is a trig function on the bottom, what's probably the most important thing to figure out first? What's going to make the bottom 0? Because that is undefined. And so our job, once again, is to find out where is cosine 0. Remember on here, cosine is the x value, correct? And so where is it 0 once again? At 90 and 270 once again. Because again, if you look at the x value, there you go, 0 and 0. And so we go back to our graph and say we know that at 90 and 270, it's going to be undefined. There are probably two more places we know then. Negative 90, and negative 90 is really the same as which one? It's the same as actually 270, and negative 270 is really the same as 90. So what do we do at places that it's undefined? Yeah, that's because we're not supposed to graph anything there, right? So we put a line there to remind ourselves not to. If you graph that, say, on a calculator, is that going to show up? No. Okay, it's not actually something that's there. So let's go to 90. Where is that? There it is. And 270. Negative 90. Negative 270. Any questions why the asymptotes are there? Should I be putting points on those little dashed lines? Well, you better not. If you do, you got some big problems. Well, we got to find some other points, so let's go and do it. Let's try 0 degrees. All right, here we go, 0 degrees. I told you it is sine over cosine, correct? At 0 degrees, which one of these two is sine? So at sine over cosine, correct? What is 0 over 1? Why did I do 0 over 1 and not 1 over 0? Yeah, it's sine over cosine. So at 0 degrees, it is 0. All right. Now, do we just draw a parabola in there like we did yesterday? Well, we got to figure out what's going on. Which means now you're going to find out that this value is actually a very clever value to choose with tangent. That one right there, assuming I put it right in the middle. Okay. 45 degrees is right here, agreed? So if you take sine is this one, so it's square root of 2 over 2 is just the sine value, correct? Over cosine is square root of 2 over 2. That is probably the strangest form of 1 that we've had so far, but it is over itself, correct? So tangent at 45 is just 1. Okay, so here's 45, so you go up to 1. Now, it does look like perhaps it's a parabola, correct? Well, let's just check this one to find out what happens. So negative 45, correct? Where are we at here? Negative 45, agreed, is right there. What is sine? It is negative square root of 2 over 2 over cosine, which is square root of 2 over 2. So it is negative 1. Does that start looking like something we have seen before? Have we seen something like, okay, it does kind of look like a line, but again, you got to go to the asymptotes. Okay, the s thing, exactly. Otherwise known as x to the third, it's very, very similar to x to the third. Okay? So now here's how I want you to start looking at this. I don't want you to have to sit there every single time and figure out those values. I want you to be able to kind of figure things out. And so obviously let's just go 180 and kind of look at it and see what we come up with. So we go over here, we go to 180, which is obviously over here. Sine is 0 over -1, so we know in the end it is just 0, correct? Is it possible that it flips around from what it did last time? It is possible. Is it possible it does the same thing? Yes. It's actually possible it does something else, right? But we know, let's face it, these are the two that are going to be the easiest to find, right? Now, what quadrant am I talking about if I'm talking about this right here? I'm talking from 90 to 180. Second quadrant, correct? So let's go look at the second quadrant, meaning that slice, correct? What is tangent going to be over there? Why is it going to be negative? Because it's going to be square root of 2 over 2 over negative square root of 2 over 2. Do you agree with that? So it's going to be negative over there, isn't it? And it's going to be -1. So it means it's going to be right there. So it's looking like it's going to do the same thing. What quadrant is this over here? It's in quadrant 3. From your quiz, you better know that quadrant 3 is what for tangent? Tangent's positive down because it's negative over negative. Okay? And so we know it's negative over negative. Oops, wrong color. So it ends up positive, and so it does the same thing. So do we have any reason to believe that it's not going to do that every time? It goes negative to positive every time, and it happens to hit where it is 0 every time right in the middle. And so what's going to happen here is it's going to be this. Obviously, would it continue if my graph continued? Yeah. And actually, I'm almost to the point where I don't care if you finish that off, if it makes you feel more comfortable with the graph. Because let's face it, we could go around this unit circle 10 times if we wanted to, right, and keep going. And same thing here, give or take. Now, who thinks they can finish off this one just if I wanted to just stop at -360? Where would it go? Does it go underneath the x-axis or above? Above. Very good. Yep. It goes up like that. There is tangent. So let's just recap. What's the very first thing we did? We found out asymptotes, because let's face it, you want to know where you're supposed to stop, right? Where you're not supposed to graph. And then with tangent, one of the very nice places is the 45s. Could I have gone to pretty much any of these other ones? Could I have gone to 30 degrees or 60 degrees? Yeah, but is that going to be an easy number to calculate? No. Look at that one. It's just sitting there. It's asking you to do it. It's 1 at 45. Now, tangent is sine over cosine. Cotangent is the reciprocal of that. Agreed? So cotangent, the one you're going to try right now, is cosine over sine. And take some time right now and do that. Perhaps 5 minutes or so here. We'll let you try that, and we'll go from there.